We've just finished up talking about the Iceman who lived over 5,000 years ago. How about we go back 3.2 million years ago to someone named Lucy? Populations of living things on Earth change over time, as we can tell by examining the evidence with the Iceman and inferring what his culture would have been like based on that evidence. Scientists use evidence and logical inference to reconstruct the past events. For example, since the mid-1800s, scientists have been piecing together the long line of species and populations from which modern humans emerged. This long line of ancestors is called a lineage. Some of the most important pieces of this complex puzzle are the fossilized skeletal remains of individual hominids that lived millions of years ago. Hominids are erect or bipedal walking primates. It includes modern humans and even extinct human-like species, like Lucy. Dated at about 3.2 million years old, the skeleton shown in the opening photo of this chapter is one of the oldest and most complete hominid fossils. Scientists named the skeleton Lucy after a popular song of the time. But how do populations of living things actually change? Well, we're going to start investigating this as we talk about Lucy. We'll once again visit both evidence and inference in this opening activity. So this is the picture of Lucy's fossilized skeleton, but there's a story that goes with this, and it can be found in our book or pasted onto these Google Slides. It's called Digging Up the Past. No one knows how Lucy died. She apparently died quietly. If a lion or leopard had killed her, her bones probably would have been splintered and crushed. Hyenas had not scavenged her, or her skeletal parts would have been scattered over a wide area. Instead, she died by the edge of an ancient lake where mud and sand covered her. She remained buried for almost 3.5 million years. Lucy lived in what is today called the Afar Desert, a remote region of northeastern Ethiopia in East Africa. The large lake that once existed there has long since dried up, and the area is now a hot and desert-like. Even though she was fully grown and probably in her 20s when she died, Lucy stood only 3.5 feet tall. Her head was a bit larger than a softball, and her brain could not have been much larger than that of a modern chimp. The shapes of her knee joint and pelvis bones indicate that she walked upright on 2 legs. For more than 3 million years, Lucy remained buried in the ancient lake bed. In 1973, Donald Johanson, pictured above, a young anthropologist from the United States, arrived in Ethiopia to look for fossils. Working with 2 Frenchmen, Maurice Taib and Yves Coppens, Johanson found a primitive primate knee joint that had washed out of a slope during a rain. It seldom rains in the Afar Desert, but when it does, the rain is heavy, cutting gullies into the gravel and the bare rock. On very rare occasions, these rains uncover ancient fossils, and as luck would have it, such a rain occurred not long before Johanson's arrival. This fossil knee joint was intriguing because it was about 3 million years old, and its structure indicated that this individual had walked erect. Because of this find, Johanson decided to return to the same ancient lake bed the following year to continue the search. If any more human-like fossils were embedded in the ground, they might be of a similar age. Johanson and his colleague, Tom Gray, had been searching all fall with no success when they parked their vehicle on the slope of a gully on the morning of November 30th, 1974. The temperature had reached 110 degrees Fahrenheit, and they were about to return to camp when Johanson noticed part of a fossilized arm bone lying on the ground partway up the slope of a gully. As he searched further, he found pieces of a skull, thigh bone, and pelvis, along with other skeletal parts, but no evidence of any tools. Remarkably, the skeletal parts all seemed to be from one individual, and a very human-like individual at that. The 2 scientists could barely contain their excitement. They named the skeleton Lucy after a song that was popular at the time. The skeleton shown in the opening photo has become one of the most famous fossils found of an early human-like animal. What did this new find mean in terms of human origins? Did gradual changes in humans, such as Lucy, eventually lead to modern humans? Some of the answers had to wait until Johansen returned to his lab at the Cleveland Museum of Natural History. There he and his colleagues spent many months in painstaking detective work, comparing Lucy with other fossils of more recent human ancestors, as well as with modern human and ape skeletons. Johansen's conclusions sharpened the debate within the scientific community about exactly when the human line split from the ape line. Most scientists agree that at a very early time, there was a single primate ancestor to both modern humans and modern apes. Recent fossil discoveries continue to add evidence to the scientific explanation of human origins. In 1994, paleontologist Tim White discovered a new species of hominid in Ethiopia. Named Ardipithecus ramidus, it dates to about 4.4 million years ago. In 2000, a team led by Bridget Sinut and Martin Pickford found another fossil that dates from 6 million years ago. Scientists are debating whether this fossil is a hominid or a chimp ancestor. In the summer of 2002, paleontologists from France discovered another hominid fossil in Chad, a country of north-central Africa, that dates from about 6 to 7 million years ago. Scientists are still working to resolve when both chimps and humans split from a common ancestor. The recent find of fossils from about 6 million years ago suggests that a common ancestor was at least that old. Will we discover more fossil remains that link humans and our most ancient ancestors? If so, will those remains help to resolve the dispute about this timing? Perhaps a future anthropologist will discover more clues and new ways to examine our existing evidence to clarify further the details of our origins. Here we can see a map of where Lucy's fossilized skeleton was found in Ethiopia in the green area. All right, so that's the story on Lucy's find. On page 88, there's another blurb that might be helpful in your activities today. It's right here. Though Lucy's complete skeleton was not recovered, scientists are still able to infer many things about her. For example, the structure of Lucy's pelvis, the bones that make up her hips, was carefully documented. Her pelvis was compared to those of modern chimps, apes, and humans. Humans walk upright. Scientists call this bipedal. Apes and chimps are knuckle walkers and are not bipedal. Lucy's pelvis shared many features with the pelvis of modern humans. From the evidence of Lucy's fossilized pelvis and the pelvis of modern humans, scientists made the inference that Lucy walked upright. Evidence from Lucy's knee bone also supports this inference. Scientists agree that hominids, apes, and chimpanzees came from one species that existed in the past. This extinct species is called the common ancestor of all three species. Recent estimates suggest that this ancestral species lived most recently about 7.3 million years ago. Chimpanzees, apes, and all other primates are not exclusively bipedal. Based on this evidence, scientists infer that the common ancestor of apes, chimpanzees, and hominids was not bipedal. What does this mean about Lucy? In the lineage from the most recent common ancestor of apes, chimps, and hominids, which existed about 7.2 million years ago, to Lucy, who lived about 3.2 million years ago, there was a change from not being bipedal to being bipedal. With an update here, this was not mentioned in the story, but a recent discovery shows that a baby Lucy was discovered. Another fossil, but of a younger version of Lucy. Would have been a 3-year-old female, and quite a complete fossil. You can read the details there that most of our fossils come from adult species. It's kind of rare for babies to fossilize, as some of their bones are not quite as completely calcified and hardened as adults are. Lucy's species scientific name is called Australopithecus afarensis. Remember, humans' scientific name is Homo sapiens. So you'll see that here, since Australopithecus is such a long word, they usually just put an A with a period, and then her species afarensis, which was from the region of the Afar Desert where she was found. Now on Google Classroom, you'll be able to find this, or from the handout given to you. You'll complete the activities and questions here, and Lucy digging up the past, writing down her evidence, describing and drawing her, and deciding if statements are evidence or inference, doing more skill practice there. Let me know if you have any questions.